Okay, so let's finish off today with example 3, which says work out the second derivative of the function y equals x squared times log of 3x plus 5. Now, because we've got a product of two different functions involving x, we must use a product rule. So let's write down our function y equals x squared times ln of 3x plus 5. So there's two x's in here and they're linked together by multiplying, so we're going to use a product rule. So using product rule, let u equal x squared, so u dash is 2x. Your v is ln of 3x plus 5, so derivative of ln is 1 over. And then you multiply by the derivative of the inside function. So the derivative of 3x plus 5 is just 3. So v dash is just 3 over 3x plus 5. So product rule says y dash is u v dash plus v u dash. So substituting it, u times v dash gives you 3x squared over 3x plus 5, and vu dash is 2x times ln of 3x plus 5. So that is our first derivative. We need to work out the second derivative, so we need to differentiate this function once more. Now there's two terms involved. This first term is a fraction. This second term is a product of x's again, functions of x's again. So this first one, we'll have to use a quotient rule to differentiate. And then the second term, we have to use a product rule to differentiate. And then our second derivative would be a combination of the derivative of these individually. So let's consider the first term. I'm going to call it g. So g of x is 3x squared over 3x plus 5. So because we're dividing, I'm going to use the quotient rule. So using quotient rule, let u be the top, so 3x squared, and let v be the bottom, so 3x plus 5. U dash would become 6x and v dash is just 3. So y, whoops, not y, because it's g dash. So quotient rule says vu dash minus uv dash over v squared. So remember, the order of the quotient rule matters at the numerator. So substituting v times u dash is 6x outside of 3x plus 5 minus u times v dash, so that's 9x squared, all over v squared, so that's 3x plus 5 all squared. So that gives us then, if we expand the top, so g dash is 6 times 3 is 18x squared, plus 6 times 5 is 30x minus 9x squared, all over 3x plus 5 squared. So that gets us 18 minus 9 is 9x squared plus 30x all over 3x plus 5 squared. I can simplify the numerator because I can factorize out 9x squared and 30x. So 9x squared and 30x have a common factor of 3x. So what's left inside is 3x plus 10. And on the bottom denominator, I still have 3x plus 5 all squared. So that's the first term, differentiating the first term of y dash. We now need to differentiate the second term of y dash. So I'm just going to say consider. I'm going to call it h because it's a different function. So 2x times ln of 3x plus 5. Again, because it's product, I'm going to use a product rule. So using product rule, let u equal 2x, so u dash is 2. Let v equals ln of 3x plus 5, so v dash is 1 over 3x plus 5 times the derivative of the inside, which is 3. So product rule says the derivative h dash is uv dash plus vu dash, which then becomes, so u times v dash is 6x over 3x plus 5 plus 2 ln of 3x plus 5. So we can finish off, because we've differentiated two terms individually, we need to combine them to find y dash dash. So therefore, the second derivative, y dash dash, is the derivative of g function, because we said that was the first term, plus the derivative of the second term and the y dash. So combining that, y dash dash, the second derivative is 6. Oh, that's not the simplified version. What was it? 3x outside of 3x plus 10 all over bracket 3x plus 5 squared. That's g dash plus h dash is 6x over 3x plus 5 plus 2 ln of 3x plus 5. So if you when you differentiate, if you have individual terms which need separate product rule and quotient rules, do it separately, and then at the end combine them back together